the recording. So, so in section 316, this is actually on page 60 in your book. It talks about vector equations. Okay. Now, vector equations have the same rules algebraically for rearranging. So, for instance, if we have the equation A plus vectorially B minus vectorially C, okay, so that's our only minus here, is equal to D. What we usually try to do with vector equations is we like to eliminate the negatives if we can, meaning we want to move them to the other side of the equation. So just like algebraic equations, when we move something from one side to the other, if it's added on one side, we would subtract it on the other. If it's subtracted on one side, we would add it to the other side. So in this case, because our C is a minus on the left-hand side of the equation, ideally, we want to try to work with all positive values. So we would move C to the other side, and we would simply then have A plus B, and then we would have our equal sign, which would be our origin in vector addition land. And then we would have D plus vectorially C, okay? So when you cross that equal sign, you can start back at the origin with the tail of that first vector. So now the rules for adding vectors remain exactly the same, okay? So equations have two sides again, and then we can take those negatives and we can push them to the other side to get them to be positive if needed, okay? Now, we're going to be working with vector equations, and we're going to be working with them in a means of solving for an unknown value or an unknown portion of a vector in a vector equation. So the last two examples we're going to go over tonight are going to be looking at this more specifically. So let's look at example 316, which is found on page 63. So I'm going to go underneath our camera here, page 63, okay? And we are going to be looking at example problem 316. So it says here that we have a vector equation that is written as follows. A plus vectorially B plus vectorially C is equal to D plus E. So in this case, this isn't going to be one where we're going to be trying to find the resultant. What we are going to try to find are some unknown quantities on two of our vectors. So as we look down below and we get the information about each one of our vectors, you're going to notice that A is on a dotted line, and notice that we have arrowheads going in either direction. So the only thing in this case, what they're representing there is that we don't know the magnitude of A, but we do know that it's horizontal. We know its direction, okay? We just know that it's horizontal. So that's what that is. So part of what we're going to be solving for in this equation is what is the magnitude, and then is it pointing left or right for A, okay? B, we know everything. We know both magnitude and direction. C, we know both magnitude and direction. D, we know both magnitude and direction. But E is another one like A. We know its direction, but we don't know its magnitude or if it's pointing up or down. So as we look at our equation on top, algebraic equations, let's talk about that first. So regular algebraic equation, how many unknowns can we have in it to solve? Just one, right? Just one. In vector equations, because each one of those vectors has two quantities to fully define it, we can have two unknowns. But the caveat is we can't have more than one unknown on either side of the equation. So notice we have an unknown magnitude of A and we have an unknown magnitude of E. Also notice that our unknown magnitude of A right here is on the left-hand side. Our unknown magnitude of E is on the right-hand side. So they are where they need to be. If E and A were on the same side, we would have to move one of them to the other side. And we would use that rule of, opposite sign, if you would. So if it's added on one side, we would subtract it. If it's subtracted on that side, we would add it. So, but in this case, they're positioned correctly, meaning we have our unknowns separated, one on either side of the equal sign. But the order that we have here is not going to work out, because if we try to start doing our vector equation with A first, we don't know where A starts or where it ends. We don't know which way it is. So we can't put that unknown quantity A as the first vector. We want to actually put it at the end of the string on the left-hand side. So you're going to notice that they rewrote the vector equation to place A and E at the ends of either side of the equation. And as we know, we can add these in any order. We'll still have the same net effect, so that's okay. So now we're going to do our actual equation is we're going to take B plus C plus A and then equal to D plus E. So let's see how we do this. It's kind of a cool process. And when you do it, it's like, oh, that kind of makes sense. So we're going to start off here by drawing what we know in terms of our known variables. So I'm going to change my object to my object layer, and I'm going to start with B. So I'm going to zoom out here. My B, turn my ortho off like I always do. It's going to be a magnitude of 100, and I'm going to hit tab, and then the angle is going to be 150 because it's coming from a standard 0. Okay. And I'm going to zoom out. Okay. So there is my first vector. I'm going to draw my arrowheads. Okay. All right. And I might as well give it the label right away. So I'm going to move. Oh, it's actually B, isn't it? I'm going to move B right about there. And then I'm going to scale it to be about that big. All right, you guys kind of getting the hang of kind of maneuvering these variables and scaling things and kind of getting them there. Okay. All right, now I'm going to do C. Okay. C is another one that I know both magnitude and direction for. This one is going straight up, and it is 124. Put my arrowheads on its end. And then I'm going to copy B over and rename it as C. All right. Next one is D. This one is 150. Tab. And this is going to be 60 degrees. So line. And I'll copy that over. Oops. To D. So I've got my 3 fully defined vectors, B, C, and D. Okay. Now what I'm going to do is I'm just going to draw lines of action for A and E. So I am going to go to object layer 2, and I'm just going to draw a random horizontal line. Okay. And I'm not even going to put arrowheads on it. I'm just going to draw it, and I'm going to copy over B variable, and I'm going to call this A. Okay. And that's going to be a horizontal line. Then I'm going to do the very same thing for E. E is going to be a vertical line. So its line of action is that, no arrowheads or anything. And I'm just going to copy over a variable E and rename that. Okay. So this is, really what we see in that example. Now, I want to show the equation in the order that I'm going to add these. So I'm just going to copy one of my variables. Since I'm starting with B, I'm going to copy this one. I'm going to put it, doesn't really matter, I don't think. So I'm going to put it B plus vectorially C plus vectorially A. That's going to be the left-hand side of our equation. And then I'm going to say equal to D plus vectorially E. So E. Okay. So that's the order that we're going to be, you know, adding the left and right sides of our equation. Now, again, we rearrange the order so that we wouldn't start either side with our unknown quantities of A and E. Okay. So since B is on the left-hand side here, we're going to start there. So I'm going to go back to my object 1, and at the tail, get rid of these variables here. At the tail of B, I'm going to show this origin. Okay, so this is, if you would, my equal sign. This is the start of, see, this is the start of the vector equation. So there's my origin. So I've got B in place. Then I'm going to add C to it. So I'm going to move C. I'm going to use its tail, and I'm going to put it at the tip of B. Okay. Now, C is right here. The tip of C on the tip of C, I'm going to place A. So I'm going to move A, and I'm going to do a nearest here. I'm going to go right about, I don't know, third of the way. And I'm just going to put it right at the end point here. I really don't know which side is going to connect. So we're just going to put that direction of A. So that takes care of the left-hand side of my equation. Notice now I am crossing over the equal sign. So that means I am starting back at my origin. So the first variable on the right-hand side is D. Let's see, I got to move this, is D. So now I'm going to move D. Its tail is going to start at the origin because I just crossed the equal sign. Okay, makes sense. Remember, the equal sign is the origin. So the tail is going to be at the origin. And now on the endpoint of D, I am going to place E. So I'm just going to do my nearest somewhere along here. And I'm going to put that at the endpoint here. Now, you'll notice that if I extend both A and E, they're going to intersect up at the top here, right? That's what I'm trying to find. Where is the intersection of these two unknown magnitudes? So to create that, I can just do the extend. I can go extend. It's going to let me do that. It's not. Dang it. I'm going to then grab my grips and then cross it over so that now I can do an extend of E up to A. And then I'm going to trim off each one of their ends on both sides. So I'm going to trim, trim this part, oops, and that part. Okay. So did everybody understand the construction that we did there for A and E? Okay. So now we know how long those vectors are going to be. But now we need to add arrowheads. Okay. So we need to go back to our equation. Let's look at A first. On the left-hand side of the equation where A is, we have B plus C plus A. So we're adding A to C. So that means the tail of A is going to be at the tip of C, and its arrowhead then is going to be on the opposite side. So I'm going to add a line for the arrowhead. I have to put it on the right layer. Let me, oopsie. On the right layer. So I'm going to go like this, put it on object B, because that's going to be that one. So that's my A. Okay. After I get E in place, then we'll do the dimensions. So now we're going to cross over the equal sign and we're going to do E. It's going to be D plus E. So tell me, is the arrowhead for E pointing up or down? Up, because if we're adding E to D, we are going to take the tail of E and we're going to put it at the tip of D, right? So that means that the arrowhead for E is also going to be right here-ish, right? There we go. Okay, so I'm just going to maneuver my E around a little bit. Now, as far as direction for these, because they're both, each one of these is horizontal and vertical, we don't need to add an angle here. So I don't need to add an angle for E or A because they're vertical and horizontal by nature. If they weren't, then I would have to add an angle as part of the answer for fully defining them. But because they're vertical and horizontal, I don't need to. But I do need to add how long they are or what's their magnitude. So I got to go endpoint to endpoint for E. To be able to see it, I've got to go to annotation, dimension, style manager, modify. I'm going to do, what do you think? 75. See what that looks like. Set as current, close. Ooh, I'm going to leave it. Probably could get by with 50, I think. Now I'm going to change it to 50. Dang it. Oopsie, not override. I want to modify. And I want to change it to, let's go to 50. I think that'll be a better size. Close. There we go. Yeah, much better size. So that means that the magnitude of E in this case is 304. And then I'm going to do that same thing for A. I'm going to do a linear dimension, endpoint to endpoint, and I get 161, 162. So let's go to our example and see how we did. So I'm going to turn the page. And you'll notice that for E, they got 306, and for A, they got 160. Let me go back. I forget my numbers. I got 161.6 and I got 304.14. How did you guys do? You got 304.9? 304.9 and one. So you got 162 and 304. Okay. So you got really close to my numbers here. Okay. 304.9. I must have something not quite right. I don't know why. That looks good. Let me see if mine up here. Did it get off? Oh, that looks good. So I'm not sure why, but there must be something just really teeny tiny off. But anyway, so there we go. Any questions on example 316? 316. So you want to add that designation here as well. Copy. And I'll say example 3.16. There we go. Make sure you do a save on this and that everything is large enough on your screenshot that I can see the items, including their dimensions. Okay. I've got 2. Jack got, okay. 303 303.9 sounds like the right number. And the 161 is good. Okay. All right. So confirmed. Not sure why mine was. I'd have to kind of go back and dig and probably redo all of them, but we're not going to take that time because we're nice and close. All right. So we've got one more example to do, and that is going to be 317. So let's look at 317. This is going to be similar to 316. We have a vector equation of A plus B minus C plus D is equal to E plus F. Okay. So you're going to notice that as we look at the vectors that we have down here, remember, vector equations, we can have 2 unknowns, and we do. We have unknown magnitude for A and unknown magnitude for D. When we have that, the key is we cannot have more than one unknown variable on a given side, okay? So in this case, we have to just make sure that since we have A and D on the same left-hand side, we're going to have to move one of them over to the other side. Okay, so we'll deal with that in just a second. But first things first, let's draw what we have here, everything in their positive orientations and any information that we know. Let's start a new file and get these in their positive orientations. So I am going to save that. I'm going to open my start file. Oops, cancel. Did I have a feeling. Start file. Oh, crap. I went over my start file. Where are my sizes? Huh? I know. I really should, but that's okay. That's okay. I feel okay. I'm good. So go ahead and start. I'm gonna I'm gonna kind of do my thing here in the background. Let's see. Okay. We'll talk about it. Yeah, we'll talk about it. I just want to get everything in that you know in either the positive form, but we'll talk about that equation and we'll kind of write it on underneath. Bless you, Christian. Okay, how many still need time to finish up their individual vectors? Anyone? We're all set? Okay. So what we're gonna do is we're gonna look underneath the camera. And I just wanna make a really quick note, so. Okay. All right. So I'm gonna go underneath my camera here. And we're gonna look at our vector equation. So this is the original vector equation that they have at the top of the example. Now, what we want to do is, first of all, wait. I missed F. Hold on. I'm sorry. I didn't put F in here. I'm like, wait a second. I didn't have an F. There is an F. There is an F. If you didn't do it, there's a 100 inches per second squared going to the left horizontally. I just realized that as I was looking. It changes to object line. So if you need to add it in there, go ahead and do that. And there is arrowhead. Sorry about that. And F. Okay. All right. So there's my F. So this is our equation. Now, what I want to do is identify what we know about each one of our vectors. So for A, there are two quantities that we're expecting. Do we know magnitude for A? No. So I'm going to put a little circle underneath here. Do we know direction? We do. We don't know if it's going up or down, but we know that it's vertically directed, right? So these two check marks. So if I have two check marks, that means it's fully defined. In this case, I have a 0. That means, oops, I don't have the magnitude, but I do have direction. So I'm going to do the same thing for B. Do I have magnitude and direction for B? I do. All right. So that one's fully defined. What about C? I know both magnitude and direction, so that's fully defined. But D is my other one where I don't know the magnitude, but I do know the direction, right? And then as I go to the other side, I know both magnitude and direction for both E and F, right? So the two that are green are A and D. Now, as we look underneath here, as we stated earlier, remember, you can have as many as 2 unknowns in one vector equation, but you can't have more than one known on a side, okay? So right now, we have an unknown here at A, we have an unknown at D, and they are both on the left-hand side of our equal sign. So we need to remove or push one of these to the other side. Now, the way that the book did it is they decided to put D on the other side, okay? So they moved D over here, okay? And by doing so, it's positive on the left. It's going to become negative on the right. So I'm going to write an equal sign here. This is going to be E plus vectorially F minus vectorially D, okay? There's nothing we can do about that because if we would move A over there, it would be negative. It's always nice if we can get rid of the negative, but we're just going to be adding the negative value. So it's going to be, that's why we needed to know subtraction of vectors. So that's here. Now, what do we have left on the left-hand side? We have A plus B minus C. Okay. Now, because A has an unknown variable, we can't start that side with A. We want to end the side with A. We always want to put it at the tail end of the side. So that's why D is over here at the end. So we are simply going to say, okay, we're going to do B minus vectorially C plus vectorially A because it's positive on this side. Does that make sense? This is where the book ends it. Okay. Now, there's one more thing I would do. I don't like dealing with negatives if I don't have to. Is there one more thing we could do to rearrange this equation to maybe get rid of one of the negatives? Christian. We could do the parenthesis thing, but that just means we're still dealing with a negative. So I'm going to move C to the other side. So we're going to have B plus vectorially A. This is our unknown. It's going to be equal to E plus vectorially F plus vectorially, I'm going to put C next because we know everything about C. We want to put all our knowns first, minus vectorially D at the end. Okay, we always put any unknown quantities that we need to determine at the end of their respective side. Okay, now we're going to do this equation. Okay, we're going to end up with the exact same answer as them, but we're going to deal with one less negative. That's all. Okay. So let's use this equation. So what I'm going to do is I'm going to write this equation on my diagram. Okay. So I'm going to grab this and I'm just going to put it down here. And I'm going to write now the equation that I'm going to do, which is B plus vectorially A equal to E plus vectorially F plus vectorially C, oopsie, come back, C plus, nope, I'm sorry, minus vectorially D, right? Yep. Okay. All right, so now I'm starting on the left-hand side here. So I already put my origin at B, okay? So B has the origin at its tail, all right? Now, on the left-hand side here, as I look at that equation, I need to add A to it. So we're gonna simply take A, we're gonna move this, and I'm just gonna go somewhere along it. I don't really know. And I'm just gonna put it at the end point or at the tip of B. So I'm gonna move my A so I can just see that this is A's line of action. I'm probably gonna have to extend or trim and all that kind of stuff, but I'm just gonna put it there. That's everything I needed on my left-hand side of my equation, right? I did A and B. Now I'm going to move to the other side of the equation. So that means E's tail is going to start at my origin. So I'm going to move E. Its tail is going to go to our origin. All right. Then on the end point of E, I'm going to add F. So I'm going to move F. Its tail is going to go to the tip of E. Then I'm going to add C to that. So I'm going to grab that and I'm going to put this here. It's ugly. And then on the end point of C, we're going to put D. So I'm going to move, grab, I'm sorry, move. Nearest, and I'm going to put this on the end point of C. Okay. All right, so everybody kind of have what we have here. Do you see that? All right. Now we've got to figure out A and D. So let's look first at A. A is going to be added to B. So if we have A right here, here is A. B was right here, right? And A then, we need to find where it intersects with D, the other side of the equation. And that happens right here. So we're going to trim away this part and that part. Oopsie, how come they both went? Undo. We're going to trim away this and that, okay? And then it looks like there's extra here. We're going to get rid of that, okay? And then we're also going to get rid of, so B's endpoint is right there. So we're going to trim away the top part of A. And A is actually going to go from the arrowhead of B here, and its arrow is going to point down along that line of action. So I'm going to change back to object 2. And A's arrowhead is here and here. And I'm going to move its variable from here, right there. Okay. So again, you have to go from B's tip straight down to where it intersected with D. Okay. I'm going to move C away from this line because C is actually this one. And then D is going to be that line. Okay. Now let's look at D. D is a minus on C. Okay. So we are going to rename this so that instead of doing a minus vectorially D, we're going to do a plus and then put parentheses, a negative D value, just like we did before. Okay. Let's see. Hang on. So that means that at the end of C, we are going to put the tail of D, okay? So at the end of C here, do you see how the tail would be here? So we're going to trim away this side, okay? And that means that it is then going to point towards A. So we would have the line. Oh, it's going to, and line. And this is going to be D. Now, this is not going to be positive D. It's going to be what? Because this is adding the negative value of D. So this is going to be a minus D. And then we can get rid of the rest of that line. Oh. Now, go ahead. Could you flip the arrow? Oopsie. I'm sorry. I thought I had my negative. I thought I put my negative.
You're tracking from C.
Mhm.
You're all out.
Right. So what you can do is you could either put it in the positive D and have the arrow go up, or you can have it at negative D going down. Does that make sense? So both of them equal the same thing, but make sure that if you do it the way that I just did it here, make sure you add vectorially the negative D, or if you put the arrowhead on the other side pointing up and to the left, that you do a minus D then. Does that make sense? Yeah. So either way, but what we're going to measure for here now is going to be the magnitude of each of those. So before we do magnitude, I'm going to zoom in here. Do you guys all see how we got A and D intersections and such, and why they're pointing in the directions they are? Does it make sense to everybody? Any questions at all? All right. Okay. All right. So then all we have to do is measure our distances. So I'll do an aligned dimension on A. Actually, that's a vertical anyway. So, see. I'm going to I know I'm crossing over, but again, remember this isn't ANSI rules, so I should be okay. And then I'm going to do another aligned dimension on D. There we go. And then we're going to compare our values. So it looks like D is 68 in the book. And A, they have at 30. I have 28.5. What did you guys get?
30.0.
Okay, so they're off just a little bit. That's okay. So there must be something minutely not quite right here. So as long as you're hanging right around 30 for A, you should be good. Okay, anybody get something awfully different? Or pretty close? Okay. All right. So process-wise, that's what we got. So I know it's kind of overlappy, so you're going to want to move things around here. And again, you can either do the negative D going down into the right, or positive D going up into the left, whatever you prefer. And then just make sure that your labels are nice and close to each one of the vectors and not like overlapping, so that I can easily compare your diagram and know where my origin is, or your origin is, and where things kind of line up. I'm going to put this right there. Okay. All right. Virtually, how'd you guys do? Any questions for the last one? Okay, I'm seeing nothing. Do we need the angle for D? No, we don't need the angle for D, because remember that was given as part of the original problem. So we know that the angle was 60 degrees. We just needed to solve for the magnitude of A and D, because those were the unknown versions, or the unknown parts of each one of those. Yeah. Any other questions on this one? Okay. This takes us to the end of chapter 3 or module 2. So what I'm going to do right now is I'm going to stop the recording and then we'll talk about the homework assignment. We'll do an overview on that. So I'm going to stop.